Hey, and welcome back to the channel, everybody. How are you all doing today? This is video 2 of Let's Drive and talk about motion simulator tech. A series I've put together to talk about my home-built motion simulator. You can see up in the right-hand corner here that I'm sitting in, that many peeps from around the world are building. And you can follow my full build tutorial series on my YouTube channel. Nobody should be without a motion simulator platform. In today's video, we're going to talk about the power plant that powers my motion simulator and gets it moving, as you're going to see in this video. This track, Deutschlandring, I hope I've pronounced that correctly, by the creator Fat Alfie, what a legend track builder he is a wonderful track for getting a bit of drifting happening. Now, by no means should I be trying to drift in a full race car. This Jaguar XJ13 is not set up for drifting. It's got racing slicks, etc. on it, but you'll see me get some drifting happening in this car. You'll be able to check out firsthand how well my traction loss system works in my 4 Degree Freedom motion sim. So for all you guys out there who love drifting, check this video out. Check out how good my traction loss is on my motion sim. Maybe you guys should get building this so then you can use a motion sim like this in the games of your choice. Okay, let's get back to talking about how my motion sim is powered, how many people power their motion sims. This is a great thing about the motion simulator build community on the whole. There's plenty of people out there with a lot of knowledge. Yes, sometimes it can be pretty hard to find the stuff that you're looking for, but over on the Dr. ADHD Motion Sim the World Discord channel, link in my YouTube channel here, guys, check it out. There's a gentleman there that started posting his build. He's building a similar motion sim to mine based on my motion sim. He's an electrical engineer and he's come up with a way to run his motion sim with a Sabertooth 2x32 using server power supplies. Go to that Discord channel and check that out. I'll be watching that with interest. So Martin's project that he's sharing over on the Dr. ADHD Motion Sim the World Discord is a really good project to be following if you want to set your motion simulator up and not have to use a battery. Batteries are not cheap these days. For a big cold crank amp battery like the one I'm using, you're going to pay around $300 for one of those batteries. So I'm watching with interest Martin's project, this custom circuit board that he's made that basically enables him to get unison power from his server power supplies and will take the regenerative energy that is sent back to the power supplies, mitigate that and manage that so it doesn't damage his power supplies. Will be really good to see working. And if that's the case, I'm probably going to be taking on his project and changing my motion sim over to the way he's going to power his. This is something that can really benefit motion sim building community on the whole. This stuff can be really hard to find out about, I know firsthand, because when I started to look for the information to build motion sim on platforms like xsimulator.net and many others, Reddit, etc., there is so much information out there. There is so much false information, true information. It's really hard to sift through that and know what you can trust and what you can't. So it's good to have knowledgeable technical people making their way to the Discord channel, and there's going to be a lot of good information on that channel that's going to help the broader community who want to build a motion sim. The other thing I'll quickly touch on, guys, is that when you're building your motion sim, you really need to read the documentation regarding the motor controllers that you purchase. A good example of this is with the Sabertooth 2x32. Make sure you read through the PDF documentation, stuff like wire sizing from your battery or your power supplies to your Sabertooth, wire sizing from your Sabertooth to your motor controllers. These things are supremely important, guys. Motion sims draw massive amounts of current. They need massive amounts of current and amps to drive the motors correctly. And if you don't have your wire sizing sorted out and correct in this application, you're going to have problems. You're going to have issues with getting enough power to your motors. You're going to stress your motors. You're going to stress your motor controllers. Make sure you get that stuff right. Read the documentation. And a big thanks to Martin for his contribution to the Discord channel so far. Cheers, mate. Appreciate it. So hopefully you've been keeping an eye on my motion sim up here in the corner. You can see some serious traction loss action at the moment. I'm starting to really sort of push the car in the fishtailing arena, and this is a bucket load of fun, guys. This is one great thing about the design of my motion sim over some others, is I really wanted to make sure I could experience like real-time G-forces that I experience in my own personal muscle car when I take it out and have a little bit of fun with that. And this motion sim does a really good job of emulating those real-world G-forces you get in your car when you lose traction in the rear end of the car. But to make those G-forces actually happen in a motion simulator, you need power. You need lots of power, and you need lots of nice clean power. Okay, let's have a look now at my setup, how I'm powering my motion simulator, how I've got my power supply set up, and how I've got my battery set up. Let me give you a quick overview of the power plant that's powering the 4 Degree of Freedom motion sim. Apologies to some of my long-time viewers. I know I've done videos on this previously, so it is a bit of a repeat, but I'm putting it in this series just so I've been able to compress everything a little bit into hopefully a little bit more of an easy to understand format. Now, this is a little bit untidy, guys. This could be a lot tidier, but it's functional and it works. As far as all the wiring goes, the potentiometer going to the Arduinos to the motor controllers, etc., etc. That side of the actual microcontrollers works quite well. Before I say any more about the way my sim is powered, guys, please make sure when you're setting up your electronics, and in my tutorials, of course, I cover all of this, make sure you've fused every part of the build, okay? You've fused from your power to your motor controllers, and you've fused between your motor controllers and your motors, all right? So the way my motion sim is powered is using 4 power supplies. Well, actually now only 3 power supplies. These 2 power supplies you see here, motor 1, motor 2, they are 50 amp power supplies, and they were originally set up to run the left motor and the right motor. So they were dedicated power supplies for each motor. I ended up running them in parallel, joining them. Then I put a multimeter on them. These have got a tunable circuit where you can put a little screwdriver in and you can increase and decrease the voltage. And with a multimeter, I set them up to be unison output. It's very important if you're going to parallel 2 power supplies together that they are putting out the same voltage within, a few millivolts. If you don't get that right, one of the power supplies will become a slave power supply, I guess, and it will be under stress and it will fail. So you do need to do that if you're going to, buy a couple of power supplies and parallel them to get more amps. By paralleling those, I was getting 100 amps, okay? Still, even though with the 100 amps, even with those tied together and 100 amps running to the Sabertooth, I was still having sometimes these power supplies going into protection mode. Now, there's a difference between how a power supply like this can deliver its amps versus how a big cold crank amp rated or amp hour rated battery can deliver amps. A battery is always going to be able to deliver amps a lot more efficiently than what a power supply can. So what I ended up doing was I ended up having a little bit of a compromise. And I did have these both parallel together, and then they were going to the battery. So the battery was also in parallel with those power supplies, and then the battery fed the Sabertooth. So I'm talking exclusively about my front 2 motors at the moment using the Sabertooth, all right? The IBT2s, there's one here, there's one here. They're powered by this power supply at the back. That's the TL power supply. That's only a 30 amp power supply for my traction loss. And then at the front, outside of my circuit box here, this closes up like this. And then on the outside, I've got this, another 30 amp power supply bolted to the side of my box. And it powers the surge rail motor, okay? Both of those power supplies at 30 amp are ample for powering those horizontal bearing axes, okay? Both the traction loss and the surge rail run on bearings, so they're not under a lot of load. They don't see the big amp draw that the front motors, okay, which are carrying all the weight of the sim right? They're carrying you or your peripherals. They really see some pretty significant amps. I think George from Sydney, and George will get involved on the Discord server soon. He's just really busy moving house and a new job, but pretty soon he's going to jump on board. And George's qualifications are in electronics as well, so he's pretty switched on with this sort of stuff. He actually tested with a voltage clamp what sort of amps were going to those motors when the rig was under load. And sometimes these front motors were seeing 60 plus amps spikes, okay? So they really pull some big amps, all right? So you've got to be able to deliver those amps consistently and cleanly if you want your sim to run consistently and cleanly. You just won't get an IBT to do that. The IBTs, they won't do it. The Sabertooth, I can verify this for, I don't know, almost a year I've used the Sabertooth for now, and it doesn't even crack a sweat. No more timeouts, no more protection mode, no more motors stopping in the middle of a game. Just constant voltage now to my motors, constant motion. So now what's happening, and the way that my front motors are being fed, because we'll talk about them because they're the challenge. The traction loss and the surge, no issues. They'll just run on power supplies by themselves, just on these crappy, cheapy Chinese power supplies. They will run on them, no problem. But the front motors, what I've done to make sure that they are never, ever short of the current voltage or amps that they require is I'm using basically a lead acid battery to deliver the amps and the current that they need. And what I've now done is instead of having the two 50 amp power supplies tied together, pumping 100 amps to the battery, which is more than the battery needs, I was probably going to run the risk of possibly, overcharging the battery, because these power supplies really they're not designed to charge a battery, okay? Really what you should probably do if you're going to use a battery is probably use a battery by itself and then get probably a DC to DC charger that you see people use in camper vans, dual battery setups, that sort of thing. Like you get a DC to DC charger that will match what your amp hour is in your battery or what your cold crank amps are, so it will keep up with your battery. Something like that will continuously keep your battery charged while it's being used. Now, in saying that, now that I've just got one power supply feeding to the battery, this is how my setup works. One of my 50 amp power supplies now comes to my battery. Okay, so it's putting power into the battery, and then the battery with a fusible link between the battery and the Sabertooth feeds the Sabertooth. Okay, so this battery basically is being float charged, for want of a better word, by that 50 amp power supply. I've set the power supply up to have its output at basically 13.7 volts, and with a multimeter on the battery, with somebody on the sim and putting the sim through its paces and me monitoring with a multimeter, I'm basically able to pretty well keep around 13 volts in the battery at all times while the sim's being used by using a 50 amp power supply to feed power to the battery. But then the sim is getting its main power from this 12 volt DC lead acid battery. Now, Dimension Engineering specify that really they finally found me. They finally found me. Guys, I might have to quickly run during this video. If suddenly the video goes off, you know that the doctor's had to flee. He's had to escape. Anyway, I digress. Dimension Engineering, who make the Sabertooth 2x32, they recommend that you use the 2x32, and indeed they're 2x60s with a battery. All right. Now, the 2x32s can be used with a power supply, but you need to set them up so then in the circuit you've got resistors that go between where the power comes into the Sabertooth and where it goes back to the battery. In the circuit, you need to design some resistors for the regenerative energy that returns to the Sabertooth, that the Sabertooth returns to the battery. Now, if you weren't using a battery and you were just running power supplies straight to your Sabertooth without this resistor circuit in line, the regen energy that comes back from your motors, okay, when the motors are reversed, and it happens all the time in the sim, this is why the Sabertooth is so good, because it's designed to handle regenerative energy that a motion sim pushes back to the Sabertooth constantly when the motors are reversed. It's designed to handle that, but it goes back to its source of power that powers the Sabertooth. So if you were just running a power supply without the proper resistor circuit, that those big amp spikes that are coming back to the Sabertooth, they're also going back to this power supply, and they're going to kill the power supply pretty quick if you don't set up that circuit with resistors, which is recommended by Dimension Engineering. So the advantage of a battery is that becomes the resistor. Okay, this is a big lead plate power soak. And of course, that energy that's coming back from the Sabertooth into the battery also charges the battery. So if you're going to use a battery, it needs to be a rechargeable battery. And it can be a lead acid, it can be a lithium, it can be a few different battery types. That's simply set up in the Dimension Engineering software. When you plug your Sabertooth into the computer, you select what sort of battery you're going to use, right? The other thing I'll point out too, if you are going to use a battery by itself, or even if you're going to set it up like I've got mine set up just with a cheap power supply that's basically keeping the battery fed instead of a car charger or a truck charger, for example. And look, I've been using this for over a year. The battery's never blown up. It's not overcharging it, and it's not ever going to do that because it struggles to keep up with the amount of power that's been taken out of that battery by my motion sim when it's being used. When the doctor's lard ass is sitting on this sim and those motors are having to do the heavy lifting with me on it and all the rest of the stuff on the sim, it's, if anything, the battery's drawing more energy than that's going back into it. Probably the thing that saves me is the fact that there's so much regen energy from the Sabertooth, or from the motors to the Sabertooth, is also going back to the battery as well, okay? So if you're going to use a battery only, or like I was trying to say before, once again I got distracted, or if you're going to set it up like I've got it set up with, say, a 50 amp power supply charging your battery, you need to set your dip switches here. Now, I don't know if you can see. I'll try and get this in focus. There we go. If you can see the number 3 dip switch, it's third up from the left-hand bottom. These dip switches are tiny, right? If you're going to use a battery like this, you need to make sure that that dip switch has been switched off. That is battery protection mode. And so if you're using a battery, you need to make sure, sorry, I'll get this back in focus. You need to make sure you've selected that in the dip switches on the Sabertooth. All right? So in a nutshell, guys, that is the way that my sim is being powered. This is working successfully, all right? I'm still really keen to see Martin's idea with this custom-made board that he's built to interface with these server power supplies, and those server power supplies will provide around 90 amps each. And being server power supplies, they're made to never have any delay in the amps that they provide. So they might very well be able to keep up with the motion sim. I'm not going to know until Martin's got his finished. He's going to share that information with us on the Together We Build Motion Sims Discord. He's going to share all that information as it comes to light, and he will either make available that circuit board for you to build and provide. He's already provided the information on where to get those server power supplies, and you'll either be able to buy that circuit board off him, because the special thing about the circuit board he's made is it will interface with those particular servers. It's not easy to use a computer power supply. You've got to short some stuff and things like that to get it to turn on and stuff like that. It's a bit fiddly. So his circuit board that he's made integrates nicely with those server power supplies. It will also allow you to get absolute unity of draw out of the 2 server power supplies, so then you won't hurt one of them. And he's got resistors built into that, so then the return energy from the Sabertooth will not affect the power supplies. It's all a part of that board. he'll either share how to build that or he will make those available for you to purchase from Martin. What a top guy. Okay, guys, that's it in a nutshell. This works. Please share how you're powering your rig, because as a community, hopefully we can all nut this out. It's a little bit of dark science, a bit of dark arts. It's a little bit experimentative. I saw George's power supply setup today. He sent me a video. In fact, I'm going to post it on, I'm definitely going to post this on the Discord channel, because, mate, when he fires that thing up, it sounds like the Starship Enterprise starting up before it goes into warp. It's certainly something to behold. A big old iron core transformer he's using. It's interesting stuff. So it's just interesting and fascinating to me the way that these things can vary so much, the way people use stuff. There's, it's a wonderful world out there, guys. So when it comes to motion sims, building them, powering them, etc., as they say, there are many ways to skin a cat. I'll leave you with a couple of miles of Fat Alfie's track. I'm not going to attempt to pronounce it again. Great track, great road meshing, feels great in the motion sim. Until I see you in the next video, you guys stay safe, stay healthy, and take it easy out there.